This is problem 32.34, and it says that you have a 400 ohm resistor, an inductor, and a capacitor in series with an AC source. The reactance of the inductor is 700 ohms, and the circuit impedance is 760 ohms. A. What are the possible values for the reactance of the capacitor? So here we want to know what XC is. It's implying that there's more than one value, so let's look at that. Z is equal to R plus XL minus XC squared to the 1/2. Let's solve for XC. We're going to have Z squared minus R is equal to XL minus XC squared. This is the important part where we have plus or minus Z squared minus R to the 1/2 is equal to XL minus XC. Because here, it doesn't matter if this is a plus or minus, you square it, you're still going to get the same on the right-hand side, right? So then we have this, and we isolate for XC, and XC is XL plus or minus Z squared minus R to the 1/2. So let's fill in our values and figure out what XC is. Therefore, XC is equal to 700 ohms plus or minus 760 ohms squared minus 400 ohms to the 1/2. And that is going to be equal to, we have, here I just did it for both of them, the positive one is 1.35 kilo ohms, and then if you take the negative sign, you get 53.8 ohms. Okay, so again, all I did is I divided this into two equations, where here we do the left plus the right, and we get 1.35 kilo ohms, this minus this, and we get 53.8 ohms. Okay, so now you're told in B that you find the power delivered to the circuit decreases as you increase the frequency. Using this information, figure out what the capacitive reactance is. Is it this, or is it this? So what does that mean? Let's first write out our equation for P, where P is equal to delta V RMS squared times R divided by Z. So that means that Z has to increase as the frequency increases, right? Because we're saying that this decreases as frequency increases. The only part of this that depends on frequency is Z, so Z has to be increasing. Let's write out what Z is again. Z is equal to R plus XL minus XC squared to the 1/2. So for this to be increasing as the frequency increases, we have to look at what XL and XC are in terms of frequency. XL is equal to omega L, XC is equal to 1 over omega C. So we see that XL has to be bigger than XC for this to work. Because here, XL depends directly on the frequency, right? Here it's angular frequency, but the proportionality is the same. So for this to increase as F increases, it means that the XL has to be bigger than the XC. So that's what we see here. And remember what XL is, it's 700 ohms. So that means down here, if XL has to be bigger than XC, XC has to be 53.8 ohms. So in B, XC is equal to 53.8 ohms. Now question C, it says, repeat what you did in A, assuming that the resistance is 200 ohms instead of 400 ohms. And the circuit impedance continues to be 760. So they're saying, okay, R, it's actually 200 ohms. And then they're saying that Z is still 760 ohms. So if we go back up here, all we're doing is changing this. But we have to repeat the equation, right? Because R was involved right here. So let's just go ahead and take this and copy that down here to calculate XC. So this is what XC is, where again, XC is going to be equal to 760 ohms plus, sorry, that's not what that is. If we go back, XL is equal to 700 ohms. So then this is going to be 700 ohms plus or minus 760 ohms squared minus 200 ohms squared, and then that's going to be to the 1/2. If we do this time, what we're going to get is equal to 700 plus or minus 733. So the two values are either negative 33 ohms when we take that negative, or 1.43 kiloohms. So now we have a bit of a problem, right? Like you can't have a negative reactance, like that doesn't exist. So that means necessarily XC has to be equal to 1.43. Okay? So the question is essentially saying if the resistance R is equal to 400 ohm and you know that this is happening, then you can kind of deduce that it has to be equal to 53.8 ohms. If, on the other hand, the resistance is equal to 200 ohms instead, you get these two answers. The only one that makes any physical sense is the positive one, so that's what you have in your system. And that is all the question's asking.